Okay, so hi everyone, Senan this side, and in this video we will solve this find the closest palindrome. This is a LeetCode daily question, and before you switch on to some other video, I will make sure that you would understand this question completely and how do you approach this question. I'll show you a lot of different examples. I'll show you in my notebook how do we actually implement this and how are we planning to do this end to end. That's what I'm going to do, and so let's start it. So given a string n representing an integer, return the closest integer not including itself, which is a palindrome. So given an n, we need to find a palindrome which is not itself. If there is a tie, return the smaller one. So this is what makes this problem a bit more challenging. And how do you define the closeness of two integers is basically the absolute difference between the two integers. Okay, so the very first thing is you need to understand what do you do if your given n is not a palindrome. What do you do in that case? Or else what could you do if n is a palindrome, right? Okay, so let's look at some test cases. You see 1 to 3 and the next closest palindrome is 1 to 1, or another example would be 1 9 1 1 1, right? 1 1 1 is also a solution, but it's not the closest, right? The closest is 1 to 1, and similarly a number above this could be 3 to 3 as well, which cannot be the solution because it's not close at all. And yep, the answer could be 131 as well, because in this case 131 would also be a palindrome, but it's not close to this at all. Now the very confusing case is basically this one. This is the test case that will mess you up literally. So the test case is if you have 1, so 1 in itself is a palindrome, right? But the answer is not a palindrome. The answer could be either 2 or 0, and the minimum of them is what? Minimum of them is 0. So you return 0. Keep this in mind because the test cases and the constraints are very important for you to know to solve this problem, and it's literally a very hard problem. So let's look at the test cases. So the length is less than 80. Okay, n consists only of digits. That is also fine. N does not have leading zeros. Okay, and n is representing an integer in the range this. This is the most important constraint. As you can see, since I would be doing this in C++, the range is very important for us because I know I can store this value in a long integer, right? Long, whatever you want, you can store this in that. So keep that in mind, and let's, before looking at the exact code, let's look at some cases that I want to discuss with you, and I'll see you in my notebook. So before we get on with the solution, I want you to understand that I'm trying to distill as much as I can, but even if for some reason you don't understand, please watch that section again. So first of all, let's look at some examples. So the examples could be for 1 to 3 is basically 1 to 1, or I just said 131 as well. The closest one is this, so I disregard this value. For 1, I could have a number as 0 or 2. Both of them is a valid closest number because they both are at a distance 1. But I will choose the smaller one, so I'll cancel this 2. For 9, what you could do? For 9, either you could go to 8 or you could go to 11, which is closer. Clearly 8 is closer at a distance of 1, so we take this and cancel this. Obviously there are more palindromes, but we are looking at palindromes that are quite close to it. Now for 10, what could you do? For 10, either you could go to 9 or you could go to 11. Both are palindromes, I'm sure of that. But which is smaller? 9 is smaller or 11 is smaller? So clearly 9 is smaller, so I cancel this 11 and we choose this 9 as our answer. Now these two cases I want you to see, but because they could be considered as a corner case to this. So for 999, and yep, so one thing to note in these cases, the answers that we got is always lesser than the number, right? That cannot always be the case. So what you could do is basically this 999, and what do you think are the possible solutions? So 989 is the next closest integer that is lesser than this, but at the same time 1001 is also an integer close to this, and you see this is closer to this at a distance 2. This is distance of 10 from this, so we take this as our answer. So what do we return is 1001. Now what would be the case with this? Either I could go for 1111, that is bigger than this, or I could go for 999. So what is the case, right? So what is the case? The case is I am going to choose this 999 because that is at a distance 2. This is at a distance 10. So I choose the one which is closer. So in this case, you realize that you could have a number that is bigger than your current number as well. And in this case, you see given uh, these two options, you choose the minimum one. One more thing to note that the length of the answer changes from here to here, from left to right, and in this case as well, length is changing. But what I want you to observe is given these two examples, these two itself are palindromes. So when you are having a palindrome itself as your input, what do you do in that case? Now I am now going to proceed with how do we actually go about solving this problem. Okay, I hope you understand whatever I tried to explain in this. Basically, some examples I have taken, some cases that I feel are important to discuss. I have shown you that. Now let's look next. Okay, now this is something that you need to observe. That is the whole, if you understand this, the whole problem is very simple for you. This is the most important. Now given a number like this, how do you construct a palindrome from this, right? So what you could do is you could take this number, place it here, take this number, place it here, this number, place it here, take this number, place it here, and leave the middle as it is, or take this, place it here itself. So if you take the first few elements and you just mirror that, so if you mirror this, right, if you mirror this, you'll get an output like this: 1 2 3 4 5 4 3 2 1. Or the other thing you could do is you could take this and mirror it in the first position, take this, mirror it to second position, take this, mirror or copy this to third position, take this, copy this to fourth position, take this, leave it as it is. So you would have the number like this. So if you observe, what did we do? We mirrored the prefix, we mirrored the suffix. These are the two possible cases, right? So I've taken the prefix and I have mirrored it, so you get this value. So this is the mirrored prefix. And or you could do is take the suffix and suffix of half length, basically suffix of the half length of the string that is given to you. Or I could just take the prefix, or let's say suffix, and you copy that too. Now which one do you think would be a closer palindrome? Either of them. In both of these cases, which one do you think is the closest palindrome? Now in this case, you see 1 is 1, 2 is matching with 2, 3 is matching with 3, 4 is matching with 4, 5 is matching with 5. And the point of difference is when you match the thousandth digit, right? So this is where the change is occurring. Now in this case, you see for the suffix, the point of difference is directly the first digit. Fine. So in this case, you would have your answer of this fixed value, which is the closest palindrome. Because this is not a palindrome itself, I think this answer to this. The case 2 would be, okay, so the case 2 is this. So again the prefix, again the suffix. Okay, so which is the closest palindrome? So let's see. 9 is matching with 9, 8 is with 8, 7 is matching with 7, 6 is matching with 6, 5 is matching with 5, and the point of discontinuity or the difference is at the thousandths position. Or you see the suffix, the point of discontinuity is this. So regardless of what the number is, what I can conclude to an extent is if you mirror the prefix, you'll get a value or get a palindrome that is closer to your solution. So we are clear with this, that we have to do something with the prefix. Fine. Now let's talk about mirroring. So what is mirroring? Mirroring is, we just said, given a string, you just copy the elements, this by this, right? So that is basically mirroring. So given two cases, the odd and the even, how do you mirror that? So what I could say is basically this is how I would be implementing in the code. You maybe find a better way to do this, but we know that we have to do everything with the prefix, right? We know we do have to do with that is what I did before this. So what I could do is I take 1 2 3 4, right? The first, because the length is even in this case, right? I take the first 4 elements, and what I do is I just create the remaining string as 4 3 2 1. I just copy paste these elements. But the case with this is if the length is odd, so I can just take 1 2 3 4 5, but rather than copying everything from 5 4 3 2 1, right, I don't use this 5. Fine, I don't use this 5 because this is odd. So while copying this, I'll just take the first 4 elements, or the even length elements, right, and just mirror that. I'll keep this as it is, and after that I'll just perform a string concatenation. like this, and you will get the prefixed mirrored like this. We are not actually going to replace this value. I'll just create a new string, concatenate, and that would be your final answer. You have 1 2 3 4 4 3 2 1 as your reversed or the palindrome, mirrored palindrome. And in this case you have 1 2 3 4 5 4 3 2 1. You don't mirror this. Okay, now we have discussed basically the cases, the general cases where you know that the string is not basically sorted, or the more general case whatever you could do. Now we are considering the case where string is already sorted, right? As I showed you previously, what you could do is basically two things, right? If the string is already sorted, so the string itself cannot be a solution. The closest palindrome is either the one after this or the one before this. So what I do is basically I take this number, the prefix, right? All our computations are based on the prefix. So I take the prefix and I subtract 1. So we have -1 here, or I could take the prefix and add 1, right? So we are doing this in the hopes of finding the next closest palindrome. Either the number could be bigger than this or could be smaller than this. And yep, so what I will do is I'll take this, and what I'll do is I'll try to mirror this. And mirroring would be done when, since the length is odd, mirroring would be done like this. You won't consider this mirroring this value. So what I'll be doing is copy the answer, which is 3 2 and 1. We'll just mirror, or what we could have done is just mirror it like this, 3 2 and 1. So given, like we already saw above, either given a string, the answer is this one or this one, or could be, if the string is already a palindrome, the answer could be this one while subtracting this whole number by 1, or the adding 1 at the middle value. So take the prefix, add 1 to that, get this, take a prefix, add, subtract 1 in this case, add 1 in this case, and just mirror as we discussed previously. So this could also be your possible answer, right? Fine. But this is true only in the case when you have a string as already a palindrome. If that is not the case, you are good with the first case, right? You just take the prefix and mirror the values, and hopefully you would get the answer. But if you have the string is already a palindrome, I can do these two things, which is add 1 and subtract 1, the prefix, and take the mirrored value. And this could be, one of these two could be a possible solution to my problem. Fine. But case 2 is, let's say if this is of even length, I could just subtract 1, I can add 1, and I just mirror all these values because the length is even of the string, right? The prefix length is even. Copy each and every element. If it were to be odd, I just copy the first element, that is not this. Okay, so not the length of the prefix but the length of the original string, right? I misspoke that. If the original length of the string is even, I take this whole and mirror this. If the length of original string is odd, I take the first length by 2 minus 1 and I just mirror that. I hope you get the mirroring part. Now let's look at the, and after this we would be done, right? So we know, okay, I'll discuss. So either if the edge cases is basically when the length of our answer changes, right? And that would be generally a corner case. So given this number 999, what I do is find the next power of 10 after this. So the next power of 10 after this is what? 1000, right? And I add 1 to it because 1001 is a palindrome. So this is where we are changing the length. Or what I could do is basically find the previous power of 10, which is 100, and subtract 1 from that. That is double line. So whichever is closer could be our answer. So in this case, if this is closer, it could be our answer. For this case, 1001, the next power of 10 after this number is basically 10,000, and you add 1 to that. That will give you a palindrome. Otherwise, if you take the previous power of 10 and you subtract 1, you get your, this could be your answer. This is triple line. This is 1001. So you see, when we discussed the very first thing, the possible or some test case, we saw this example, right? So the answer for this is this. Answer of this is now. What I do in the end is basically, we had 5 options. First, just mirror the number. Just mirror the number using the prefix value. Second case, what you could do is you add 1 and mirror. Third case is you subtract 1 and mirror. And the fourth case would be find next power of 10 plus 1 could be your answer, or previous power of 10 minus 1 could be your answer, right? So I know that mirroring could give me an answer, possibly because this first would give me an answer when I know that my string is not a palindrome in itself, right? In that case, I think that this would give you the correct answer. In the case 2, when the number itself a palindrome, you need to change something, right? Add to the mirrored value 1, the prefix, add 1 to the prefix, subtract 1 from the prefix and mirror that. That could be your possible answer. Or these are a type of corner cases. You can find the next power of 10 and add 1, or find the previous power of 10 and subtract 1. These are the 5 possible cases, and whenever you give this a number, it would either fall into one of these categories or multiple of them, but definitely in one of these, and would possibly give you the answer. Okay, so that is what I had to say all about this question, and let's look at the code, because even if you know, if you even if you understand each and everything that you see here, the only thing you are worried about is how do you actually implement that, right? So that is what we are going to see now, and let's go to my LeetCode account. Okay, so we are back on my screen, and let's look at the private functions that I have. So reverse string is a function that takes a string, reverses that, and returns a copy of that string, right? We are passing by value, so we have a copied string. Why do I need this? Given I need to mirror a string, right? So I give the half string, which is the prefix, and a list of possible answers that I could have. I shown you 5 possible cases, right? So this vector would be storing those values. Now if you see, I since we had to mirror it accordingly if the length of the string is odd or even, right? So if the length is odd, I just remove the last element from this, and I reverse that, and I keep that as a possible answer. So basically, if you see the mirroring thing that I did, fix, right, reversed it and appended it to my original string. If the length is even, we are not going to pop back. Otherwise, I get the prefix as the original half string, I get the suffix as reversed of this half string, and if it is of odd length, we would have the right amount of elements that we need to reverse, and in the end I just return the whole string, combined string, which would be a possible answer. And stol is basically string too long, right? This is what we are going to do, and this would give us a mirrored string, and it would directly store it into this possible answers array. And in the end, we would iterate through this possible answers array, and we would try to find the solution. So I think you're comfortable with this two functions. Now let us actually look at the nearest palindrome. So first of all, I get the length and I get the original number, which is the string too long n, and I store this as a long. Now I have a listable answers, right? Now first of all, I get the prefix, right? So how do I get that? I take the length, I add 1, and by 2, this length is odd, or even this would give me the correct middle part. So if my length is 9, I need to have the first 5 elements. If my length is even, let's say 8, I need to have the first 4 elements. So this is the way I extract the prefix. So what I do is I find the incremented prefix, the case 2 and 3 that I showed you. I add 1 to the prefix, I subtract 1 to the, this is what I'm doing. I add 1 to the prefix, I subtract 1 to the, now what I do is I convert them back to a string, right, using the toString function. So incremented and decremented string, and what I do is I say take the decremented string, mirror it, and so this length is basically keeping track of if our length of the original string is odd or even, because based on that we doing the mirroring, right? We discussed about odd and even before. So I take the decremented string, I try to reverse that, put it into my answer. Or I take the incremented string, I put that into my answer. I mirror it and then I put back that into my answer. Or I take this as just this prefix, same element, and I take that into my answer. Now the edge cases that I discussed is basically I find the next power of 10, I find the previous power of 10, basically the previous power of 10, and the next power of 10, and I add that to my list. So if you observe, whatever we would have in our possible answers would be a palindromic number. So the number would be a palindrome. Whatever the possible answers are, it would be stored in the list. Now what I would do is, okay, so before, I hope you understand what we are doing this, because this is the whole crux of the whole of this question. If you understand this, the final answer is just a search method. So let me go through this briefly. I find the prefix, I decremented the prefix and converted that to string, incremented and decremented string. Now after that, I try to mirror the strings or decremented string, the prefix and the incremented string. I take that into my answer and I look at the two edge cases in which we are actually going to change the length of the string itself, right? So in that case, now what I do is basically I run a for loop. So what I do is long candidate, I iterate over all the possible answers, and I say if candidate is not the original number, right? So if for some reason you had a palindrome as a substring, the original this string is a palindrome itself. So when you do the mirror string of prefix, you would again get back the same n as well in your answer, so you would not even consider that a possible solution. Now what I do is I check if absolute value of candidate is less than the original number that we right. So if this is the case, the possible candidate in this possible answers that is not the original number, I check the absolute difference, the distance of this candidate from the original number, and if it is less than what we already had, the possible answers minus original number, if this is the let's say this is less than that, that means we have an answer that is more, we have a palindrome that is more closer to our original number. So I initialize this answer to the candidate we found in this possible answers. Or the other thing could be if my absolute difference of this two is exactly the same, right? So I have found another, so if I have found a candidate that is at same distance as what I have stored in my answer, but this new candidate is smaller than the answer, right? This part of the code is because absolute difference. Okay, so return the smaller one. To keep this track, I do this again, this or statement with this. If I have found a solution that is equally closer to what the answer is, and that answer is less than, so the candidate is less than the answer, I update that back to my answer, and in the end we would have an integer stored in this long variable. I just convert that to string and I return that to my answer. To do this, I took multiple test cases just to see if this is running fine, the cases, and yep, what I found was it's working on most of the things that I thought was an error. So yep, that was the whole solution of this problem. This is a bit complicated, I know, difficult to understand, I get that as well. It is not easy to figure this out on your own. You have to think a lot, right? You have to think, you have to, how do you actually get a number that is closer to this current number, right? You have to test the cases if the number that you have is a palindrome or not, and if it is, how do you change that, as we cannot return the same number as itself, because even if there is palindrome, that is not the answer. We need an answer that is closer to that palindrome. And so this is what this, which makes this question difficult. So we had incremented case, decremented case, no increment or decrement, and the possible edge cases where you change the length of the answer. So yep, that is, as you could see, this is basically accepted. And yep, thanks for watching. This was my implementation, and I'll see you in the next video.